Welcome, everyone. Thank you for joining us today for this exciting webinar from Silicon Tech on building AI teams with multi-agents. I'm thrilled to introduce Marcelo, our expert speaker for today, who will bring his expertise in AI and its use on the AWS cloud. Before we start, let me remind you that you can get in touch with us after this presentation and schedule one-on-one meetings with the tech team, and we will be more than happy to assist you. Without further ado, over to you, Marcelo.
Thanks, Will. Just give me a second. Let me share my screen. Please confirm that you see it.
Yes, perfect.
Cool. All right. So hello and welcome, everyone. Thank you for joining today. In the next 30 minutes, we'll look at how multi-agent systems, which are AI tools that work together, can automate telecom tasks using AWS and Vonage. This is a specific use case that we are going to be showing today, but it could be applicable to any other industry. Let's start with the big challenge. Telecom companies need to handle thousands of customer requests every day, like sending SMS alerts, verifying identities, managing voice calls. And by doing this manually, this is slow, it is expensive, and this is error-prone. That's where multi-agent systems come in. These are smart AI programs that plan tasks, use tools like, for example, Vonage APIs. And these APIs are like bridges between apps. And remember, past interactions to solve problems faster. Today, we are going to break down three things. First, what agents are. Think of them as virtual assistants. One agent might check if a user is real using a verification API. Another can fetch data from a database. And the third one can send an SMS or make a voice call to reply that information using another API. We're also going to look at why telecom needs this. Agents can automate things like fraud detection, catching like fake SIM cards, for example, answering customer support questions 24/7, or routing calls without human help. So how do we build them? We build them a real telecom workflow using Bedrock. This is AWS tool for building agents, and Vonage APIs. You're going to see how agents work together to verify a user's identity, to pull their account details from a database, and to send a response. We're going to show how you can configure that, and this is done all in seconds. By the end, you're going to see how these systems can save time, cut costs, and make customers happier. So let's go. First, let's break down what agents are. Imagine a customer service scenario, any industry, like banking, healthcare, or retail. A user asks a question. For instance, what's my order status? Or how do I reset my password? Instead of a human answering, an agent, an AI program, steps in. Agents are like digital assistants that do three key things. First, they perceive. They take in information from their environment. They are aware of what's happening then. This could be a text query, a voice command, or a data from a system. For example, if you ask, what's my account balance? The agent hears this request. Then they plan. They use reasoning frameworks like ReAct, a method where they reason and act step by step, or chain of thought prompting. This is breaking tasks into smaller steps to figure out what to do next. Let's say a user wants to book a flight. The agent might plan. Step 1, check dates. Step 2, fetch flight options from an API. Step 3, confirm payment. Third, they act. Agents use tools like APIs, databases, or code to get things done. For instance, to send an SMS, they might call the Bonnet Messages API. To check inventory, they query a database. Now, multi-agent systems take this further. Instead of one agent doing everything, you have a team. A supervisor agent coordinates specialized agents. For example, an authorization agent verifies the data of the user, and it verifies the identity is the one that is saying it is. Then you have a data agent that fetches information, and the communication agent can send updates of what's happening via SMS or email. So this teamwork is powerful. In healthcare, for example, agents could check symptoms and schedule appointments. In telecom, they might automate customer support or fraud checks. And the key idea is agents handle repetitive tasks, reduce errors, and scale effortlessly, freeing humans to focus on complex problems. So in short, agents are AI co-workers. They are always on, they're precise, and they're adaptable. Let's talk about why telecom companies are turning to multi-agent systems. Mention this. A telecom provider gets millions of daily requests, like checking data usage, reporting lost SIM cards, or asking about billing. Handling this manually is slow, expensive, and it is risky. Here's where agents shine. First challenge, high volume interactions. Every day, customers flood channels like SMS, voice calls, and apps. Human teams can't scale to meet this demand. Agents automate repetitive tasks like answering what's my balance or resetting password, freeing staff for complex issues or things or any other tasks that really require a human. For example, agents can process tens of thousands of SMS queries in minutes using Monash Messages API. The second challenge is fraud. SIM swap scams, spam calls, and fake accounts cost telecom billions a year. These multi-agent systems fight back. An agent can spot suspicious activity like sudden SIM changes using for this, you can use a specific API that Bonnet has, which is the number inside the API. It flags risks in real time. You can block the fraud and alert the user via SMS. And the third challenge, the multi-channel chaos. Customers expect help via SMS, voice, WhatsApp, video, all at once. You can have agents unifying these channels. For instance, a customer starts a voice call, gets routed to an IVR agent, and then it switches to SMS for getting the one-time password. Then the communication can continue via voice or SMS. You can configure it any way you want. So the benefits are automation, so no more manual password resets or balance checks, speed. Agents can work in parallel. So while one agent is verifying the user one-time password, the other one is fetching the data. And accuracy. You reduce human errors and fraud detection or problems that you can have in billing. So in short, telecoms face unique pressures, volume, security, and complexity. And multi-agent systems can turn this chaos into order, saving time, money, and trust from the customers. Now, let's talk about the tools that make telecom automation possible. In this specific case, we are going to be talking about Bonnet and the APIs that it offers. APIs are like bridges between your agents and the real world. They let your AI programs send SMS, make calls, or verify identities. For telecom, this provider uses a 4P set of APIs. You have the Verify API, which handles the OTP authentication. Imagine the customer wants to reset their password. Instead of a human sending a code, an AI agent, uses this API to automatically generate and send a one-time password via SMS or a voice call. And this is fast, this is secure, and this reduces any fraud that can happen. You have also the Messages API. This lets agents communicate via SMS, WhatsApp, or social channels. For example, if a customer asks, what's my data usage? An agent can fetch the data from a database and reply through SMS or through voice. Or you can send bulk alerts to thousands of users if the case requires. And you also have the Voice API, and this power the core routing and IVR systems. So let's say a customer calls to complain about billing. The Voice API routes them to an automated menu in the IVR. So where an agent guides them step by step, like press 1 for billing or transfer them to a human if needed. And you also have the Video API for real-time collaboration. Agents can start video calls, so a technician can AI technician can guide the customer through fixing a router or something in the computer. So you have these 3 use cases, for example, customer support, mass calling. You can protect the privacy by hiding the real number using the Voice API, and you can also send these bulk SMSs. For example, there's an outage alert, and you can send 10,000 of SMSs alerting the user of that. How do we implement this? This is where Amazon and Bedrock comes in. Amazon Bedrock is the solution from AWS for building intelligent multi-agent systems. Bedrock agents are like a factory for creating AI teams that work together seamlessly. Here's how they work. First, multi-agent collaboration. Bedrock lets you create specialized agents, like a customer service team. For example, you have a supervisor that might handle a user request, check the data usage. It splits the task into an authentication agent that verifies the user identity using we can use, for instance, the Vonage Verify API for this case. You can also have a data agent pulling the data from the database, and you can have a communication agent sending the results via an SMS using the Messages API. Second, retrieval augmented generation, RAG. And this is a fancy term for adding real-time data to AI responses. Let's say a customer asks, why is my billing higher this month? The agent doesn't guess. It pulls records, the billing records from the database, and then explain the charges. Third, you can configure memory retention. The agent remembers or can remember past interactions. If a customer says, I called last week about the lost SIM card, the agent recalls the case and skips repetitive questions. This makes conversation faster and more personal. And for telecom, Bedrock agents integrate smoothly with Vonage APIs. So you need to send an SMS, use the Messages API. You need to block a SIM swap, use the Number Insights API. The supervisor agent handles the workflow, ensuring tasks like identity checks, data retrieval, and SMS replies. So let's dive into our demo. Imagine a customer send a text message saying, check my account balance and recent transactions. Here's how a multi-agent system in Bedrock paired with Vonage APIs handles this. Step 1, the user sends the request. This could be via SMS, a mobile app, or a voice call. For this demo, we are going to show it inside the Bedrock console, so you can see exactly what is happening at the time that the message is being sent and received. But this can have any front or any UI that you like. The message lands in the system, and the supervisor takes charge. The job is to break down the task and assign to the right agents. So the step 2, verify identity. The supervisor delegates this to the authentication agent, which triggers the Verify API. The customer receives a one-time password via SMS. Once they reply with the correct code, the authentication agent confirms their identity. So this is happening in seconds without human intervention. Then once the user is verified, you can fetch the data. That's where the data agent generates. Using the retrieval augmented generation, it searches the company knowledge base, like billing database or transaction logs, to find the customer's balance and recent activity. And this ensures that the agent is not guessing, it is using real-time, real up-to-date information. And then you have all those pieces and you have to coordinate it. And then you have, again, the supervisor agent compiling the results. And if we were showing the full workflow, the communication agent would send an SMS via the message API with the balance and transaction. Today, we will focus on the authentication and the data steps, but it's the same principle. Agents automate the entire chain. Okay, these are the steps. This is a small diagram telling you exactly what I just mentioned, what is happening in each of the messages, where this dispatcher or supervisor agent takes the request and then routes it accordingly to the other agents. Okay, so let me switch to my console so we can see exactly how this works. Okay, great. So as I mentioned, this all works inside Amazon Bedrock. This is a nice way of configuring agents and configuring all the actions that these agents can do and how they can coordinate each other. For this, I'm going to show you the different pieces that we have. We have a dispatcher agent. Then we have an authentication and auth agent. This agent is going to be in charge of using this tool. Let me show you. This tool inside this action group, which is a program, a Lambda function that is going to be calling Bonuses API, and is going to asking for the generation of this code, and it is going to check back on this code when it's needed. And we also have this data retrieval agent that also has access to some tools, but in this case, they are going to check on the database what the information for this customer is. Behind the scenes of this, we have Lambda functions with these are these programs that make the calls to the APIs. In this case, this is for the OTP generation and verification. For this one, this is the data gathering. In this case, we only have a small JSON file on an S3 with the customer information, but this can be any type of database. And you can also have this SMS sending function, which would be used for an agent in charge of communication. All these Lambda, all these programs are made available through an API that has different endpoints. When you call these endpoints, they are executed with the information that you provide. This information is going to be sent by the agents. So let's going to see the flow. Imagine this is this dispatcher agent or the supervisor agent. When the user comes, this agent is going to receive the message. As I mentioned before, this can be through any type of user interface. In this case, I'm going to show you in this chat box. Imagine I'm a user and say, I need to check my account balance and recent transactions. I misspelled it, but doesn't matter, the transactions. Okay. Now let's see what's happening here. Okay, here what happens is this agent interpreted my request and said, okay, but first you have to verify who you are. Then we are going to be sending an OTP to you just to check you are really who you are. Then this agent invokes the authentication agent, which is the one that generated this one-time password that was sent to my phone. Let me check my messages. All right, so the OTP is I send the OTP to the dispatcher agent, and now the dispatcher agent is checking back with the authentication agent whether this OTP is really the correct one. Okay, so it verifies that it's okay. So to proceed checking the account, they're going to need my customer ID. Okay, I'm going to provide my customer ID. And then what happens? The dispatcher agent knows that they has to involve the data retrieval agent now, which comes into play here. And armed with my customer ID, got the information from the database, saying my balance and answering my question also about the recent transaction. For each of these interactions, you can see exactly what is happening here and what is the reasoning that the agent is doing here, which is a long prompt saying what information is getting, what tools do they have, and how this agent is choosing the right one for each of the steps. So as you see, this can be easily configured, and you can easily see here how the interaction between agents functions when each of the agent is involved, and how much time is going to be taken for any of the answers. This is after having this information, you can also optimize it by making little adjustments in the, it could be in the prompts, or it could be in the APIs that is calling, or any other of the tools that it's using. Let me fetch back the presentation. Okay, let me start again because I'm not seeing that here. Here you can see it.
Yep, perfect.
Okay, cool. Okay, so well, what are the benefits and the use cases for this? So let's zoom out and look at the bigger picture. The agent systems, the multi-agent systems aren't just cool tech, they deliver real world value. Let's start with the benefits. First, they reduce costs. You can automate repetitive tasks, and you have 24/7 support. So the customers don't work from 9 to 5. So you can have these agents that never sleep, taking care of any type of support 24/7. And the use cases, as I mentioned, for detection, for things like SIM swap, mask calling to ensure privacy. You can send bulk SMS alerts. You can have an AI-powered IVR, much more intelligent than just a normal menu that says press 1 or 2 or 5. So these examples show how agents turn challenges into opportunities by automating security, privacy, and communication. Businesses not only save money, but also can build trust. Customers get a faster and safer service, whether they're verifying a transaction or making a call. I don't know, Will, if you have received any questions.
There are a few that we have on YouTube.
Okay.
So we have one that says that a person is getting Lambda permissions with S3 and Bedrock. So interesting to know what's the right way to set up permissions.
Okay, that's a great question. I'm guessing that is using S3 as storage for this data that the agent is trying to fetch from Bedrock. So you need 3 layers of permissions. Lambda need permissions to access S3 using an AAM policy for get object and list bucket. Bedrock needs permission to invoke Lambda. For that, you use a resource-based policy. And if you're using an API gateway, it needs also permission to invoke the Lambda. And we recommend sending this permission incrementally and testing each layer. So, but yeah, this is something that AWS has. It can tend to get confusing, but if you go step by step and reasoning, okay, this is going to connect to this. So this needs permission to access this. In each of the steps of the architecture, you are not going to have any problems. Is there another one?
Great, thanks, Marcel. Yeah, second question will be, how do you debug when the response format isn't working between Bedrock and Lambda?
Okay, this is something that happens too, because you're having this LLM generating outputs that are going to be fed to a Lambda, and then you're going to have a Lambda generating things that have to be fed to the agent, and both have to be understood in both ways. So the key is to understand that Bedrock expects a specific response structure. So you can start by testing the Lambda directly with test events inside the Lambda that match the Bedrock format. You use print statements to log the event structure and ensure the response includes all required fields like message version, for example, response body and sessions attributes. For this, you have to use CloudWatch logs. You have to locate the Lambda that you are using, and you can see all the details there.
Awesome. One more question.
Okay.
From the chat. What's the best way to test a multi-agent workflow like OTP verification followed by a data retrieval?
Okay, similar to what I mentioned before, you test each component separately first. You verify your OTP that the OTP Lambda works, and then your data retrieval Lambda, and finally the agent-to-agent handoff. Use the agent instructions to ensure proper sequencing and maintain session attributes to pass the information between the agents. Always start with a simple happy path before adding error handling.
Okay, perfect. That sounds good. So we have one more question on the chat that I was about to answer. I can maybe just say it out loud. So we have a question that says, is it possible to reduce the amount of agents by making a single agent do more than one thing? And what are the disadvantages to this? And what I was about to say is that there is the ability to set up a multifunctional agent, but the disadvantage of that will be trying to build something that is too complex to achieve very diverse tasks. So yeah, I will use multifunctional agents only if you have tasks that are closely related. Otherwise, you will be spending too much time and effort on getting that multi-purpose model. But yeah.
Yeah, I completely agree. And the other thing is that you're making the maintenance of this agent too complex. If you have different teams of different developers and there are experts in these different tasks that these agents can do, they all will be working inside the same agent, and they have to be more careful with the versions that are working to not affect one to another. So yeah, it is always better to separate functions. So you can have an agent that is really an expert on one thing and another one that is a real expert on another.
Great. Yep, that will be it about the questions.
Great. So let's wrap up. Today we have seen how multi-agent systems powered by AWS Bedrock and Monash APIs can transform complex workflows into automated, scalable solutions. Here's the big takeaway. Agents aren't just a trend, they're a practical way to tackle real-world problems, whether you are in telecom, healthcare, retail, or anything. Key takeaways: agents work like a team. A supervisor, specialized agents, a supervisor makes this coordination between these specialized agents to verify identities, fetch data, communicate with any API or any service just in seconds. These APIs are like the bridge. The agents act in the real world, from sending OTPs via SMS or getting information or doing anything that can be done through any existing program that has access to an API. And Bedrock simplifies everything with built-in security, memory, and RAG. Is one-stop shop for building intelligent agent systems. So what's next? Start small, automate one workflow like password resets or balance checks using agents. You don't try to go all at once. You can explore Bedrock and you can explore Monash. You can explore any services that provides an API. Much of this service they have, like AWS and Monash, they have free tiers and they have lots of tutorials so you can experiment. You always have to think security first. Use tools like Bedrock guardrails. That we don't have time to mention it, but there's a whole lot of things that can be done with guardrails. And you can have this verify API to protect the systems. Yeah, so the future is here. Imagine a world where agents handle 80% of routine tasks while your team focuses on innovation. Whether it's fighting fraud, managing customer support, or ensuring privacy, these multi-agent systems are key. Thank you for joining us today. If you're curious about building your own agents, reach out. We would love to help you get started. Thank you.